Hello, welcome to LeetCode Solver, and I am a LeetCode Solver. Today we are going to solve 20th problem of 30-day LeetCoding challenge. The problem name is construct binary search tree. Well, construct binary search tree from preorder traversal. Return the root node of a binary search tree that matches the given preorder traversal. Well, binary search tree is a binary tree where every node, any descendant of node.left has value which is less than node.val. So this is a binary search tree where the current node is 8 and 5, the tree formed at the root of 5 is left subtree, and all the values in this left subtree are smaller than 8, strictly smaller than 8 according to definition, and all the values in this right subtree are strictly greater than node.val, current node value, which is 8, which is greater than 10, and 12 are greater than 8. Well, this is a binary search tree, and the order given to us is preorder traversal. Basically, in tree we have three types of order, which is preorder, in order, and post order traversal exists for tree traversal. So for binary tree, preorder, as the name suggests, we will traverse the node first, then left subtree and right subtree, and as name suggests, in order. So the current node will be in the middle, so there will be first left subtree, and then after current node, and then after right subtree. Well, now as the name suggests, post order, the current node will be processed later. So left subtree and right subtree and current node. So order of process of current node determine the name of the order. So in pre-order, the order of process is at the first. So current node will be processed first. And in order, current node will be processed in the middle. And in post order, current node will be processed later. And the order of left and right is always left is higher precedence. Left has higher precedence. So in this way, we have pre-order. We are given a pre-order traversal basically, which is processing current node, which is 8 if we start from the root node, and then after we will go to the left subtree, and in the left subtree we do the same thing recursively. So we will process the first node 5 and give call to the recursive call to the left node, and the left node has 1 which will be printed, okay, and 1 has nothing in the left side. So the output, I mean the representation is different. Well, this is pre-order traversal array. So after one processed, there is nothing to process. So there was one thing, it will give calls back to the stack which contains 5, and one stack is still have something to process. So which will now give call to the 7, which is right subtree, because left subtree are already processed, and it prints 7, and it has nothing to left and right, so it gives calls back to the this, and this has everything processed, and it will be updated from the stack again, and it will gives call to the 8, and it has something to process, and it gives call to the right subtree. Right subtree has basically right subtree try to do the same, which will print the current node, which is 10. After 7, 10 will be processed, so 10 is here, and then after 10 we will try to do the same thing, give call to the left has nothing to do, and it gives call to the right side, which has 12. So tobel will be processed then, and after process of tobel, it will give called back to 8. It has nothing to do, it will also pop out, and it will give called to the 8 which has nothing to do now, it will also popped out. In this way the recursive calls internally works in pre-order traversal. If we do recursively, the recursion will store all the values in stacks and processed in this manner, which I explained just now. Now let's think about the solution of the problem. The problem actually wants us to construct this binary search tree from the given input, constructing the binary search tree itself. How we can construct binary search tree? Binary search tree basically have three information that we need to process. We need to have, first of all, we need to have value, then after we need to have left subtree, and then after we need to have right subtree. So basically we can get left and right subtree recursively, and the current value can be processed according to given vector itself. Like current node for here is 8, which is the uh, first element in the given pre-order traversal, which is always the top element, I mean the root element of the given tree. Well, we can easily put it here, and we have to find the left subtree and right subtree. For that, what we can do is we have the information that every value in its left subtree will be smaller, so which will be processed first as well. So 5, 1 and 7, if we go in this way, 5 is smaller, 1 is smaller, 7 is smaller. So the smaller value will reside in left subtree, okay, and this left subtree is itself is a tree in its own. So we can expect, we can give call to the this subarray, like this as a whole is a array itself which we are going to process. In the meanwhile, we find a subarray which have similar way of processing, so we give call to the this subarray, and which will process us and return us the left subtree. And then after we have remaining information available, which is greater than 8 itself, so 10 and 12, so which will reside in this direction, because these are greater than 8, and this will reside in this direction, left subtree. And left subtree can be also formed in the similar way that we are gonna form this as a whole tree. Well, the only things that we need to know is which one is the partition that will partition left subtree and right subtree. So basically, if we traverse over the current range of the element, then we see that the element which is bigger than the uh, current value which will be reside on the top of the array, top of the uh, root node, which will be the root node. The one value which is greater than this one will separate the given pre-order traversal of the tree. So we basically have to somehow find 10, then after we can process left left subarray to find the left subtree, and right subarray to find the right subtree. Well, now how can we find 10? The one which will determine us the partition of the left subtree and right subtree. Well, first let's see the pattern of our uh, pre-order traversal pattern of BST, which will be like the first element will always be root value, and all the value will be left subtree value, say left values, and all the values will be right values. Well, in this way, the preorder will be organized. And now the challenge is to find this partition, this one, which will separate the left subtree and the right subtree. Well, in order to find that, we can every time whenever we are processing some array, some preorder cell array, then we can just iterate over. Suppose this value is x, then we can just iterate over to the array and we find the value which is greater than x and stop right there. So we'll go towards the right side and we'll stop. We'll find the first element which is greater than x and stop there, which is basically partition. The left subtree will be formed from the this vector, which is, say, if the current range of element is something like this is a low value and this is a high value index. Initially the index is like 0 and n minus 1. Say n is size of preorder cell vector, preorder vector, then low and high will determine the range of array to be processed. Well, the left subtree can be processed from the index starting from low plus 1 and up to this index. Say if we find this index, say we can say this as a right index. Well, this right index is responsible for partition, so which is greater than x. So we can say right index minus 1. So this range will give us left subtree, and for right subtree we can find out using another range, which is right index starting from right index up to high range. So basically if we pass the range in a recursive solution and internally if we find the right index somehow, then we can easily construct left subtree and right subtree recursively, and we can easily construct the current node. So basically the question asks us to find the root node of the binary search tree, which is the combination of left subtree and right subtree and current value. Current value is the first one, and left subtree can be found recursively, and right values can also be found recursively. Well, let's see if we how to find this right index. So the way we can find the right index is, one way is brute force way is just to iterate over the given range and find the one which is greater than x. So if we do this, the time complexity would be, as we are processing n number of nodes, and in every node we are traversing over the range. So in worst case the range can be of size n, and then after n minus 1 and then after n minus 2, so size can be up to n. So let's say worst case complexity is big O of n square. If we traverse and find right index, then Another way can be, in order to find the right index, we can, if we see the pattern of the array is like there is a left values is always smaller than x. So it's kind of say that if this is x, then every value is smaller than x. This value is also smaller than x. This value is smaller than x, smaller than x, and smaller than x. Then after there are values which is the value this is greater than x, also greater than x, greater than x, greater than x, greater than x. So there is a pattern that if all the values are over first range are smaller than x, and all the values in the second range are greater than x. So we can easily apply binary search over here. The property is like the this is in sorted manner, because if we consider this all the values greater less than x as a 0 and all the values greater than x as a 1, then it is in ordered manner like 0 0 0 0 and 1 1 1 1, and we have to find the one which is bigger than x. Among bigger than x, we have to find the lower bound of the values. So we can easily do this using binary search. So every step we can apply binary search, and we will uh, obtain the complexity of big O of log n in this case. So this is the time complexity. Well, let's talk about space complexity. What will be the space complexity? If we do the recursive solution, then basically the stack will store all those information. And if we think about the uh, tree which is linear, uh, so in that case we have to store every node's information in a stack. So worst case complexity will be big O of n. Let's go through the implementation. Let's find the n hi, which will be the size of the preorder, which will be the size of the tree, all the nodes of the tree, preorder over here, preorder size, and let's find the range. Low is 0 and high is equals n minus 1, the first size, and let's call a helper method bst from preorder helper, and let's pass the range first, low and high, and we also require preorder array in order to find the value. And what else? That's it. Let's implement this method which will return us tree node, and it takes three argument, low and high, which is a range, and vector. Preorder. Well, now let's think about the best case. Best case is definitely if low is greater than high. In such cases, we can simply return null. Now, if now we have a current value which is say x, which can be preorder low, because we will have at least one element if low is equals to high. This is current value. Now if we see that low is equals to high, only one value range, then we can simply return the tree node itself. So let's define tree node first. tree node with the current value, and left and right subtree as a null entry. So let's current node, say this is a variable, so current node will be equals to new, let's use constructor tree node with the current value, current value, so which contains as we see the constructor left and right subtree are null. So if the range is only one element, then we can simply return current node. Okay, now the element are more than one. We can find a right index which contains the element which is just greater than x. So let's define it as a right index. Right index is, in worst case, say right index is greater than high. Simply we will try to find the right index and minimize the index among all the elements which is greater than x. Say let's do a binary search in the range. So let's pass say right index, which we will get it from a binary search. So say binary search let's pass all these values, low and high and pre-order, and if in case right index do not exist, let's return -1 so that we can process further. So let's define binary search right index. Okay, now let's do a binary search. Let's find the index. Let's say int max, and we'll try to minimize the index. So let's also define let's say low and high. We can easily use this low and high. And let's find mid value, which is low plus high divided by 2. Find the mid one and see that if it is greater than pre-order of current value, the mid value, if it is greater than well, low. So pre-order, no, let's define that first value. Or whatever we are doing binary search. So let's also pass what we are doing binary search. Let's say x is actually current value. Instead of finding, we can also find it here, but let's say we pass it int x. So if this is greater than x, then we will try to minimize our index. So index will be minimum among index and say mid, because it satisfies the condition, and if it satisfies the condition we will try to minimize it, and we'll go towards this condition is satisfied, so we are towards the right, we'll go towards the left. So in order to go towards the left half of binary search, we can do it through by changing the high range, which will be equal to mid minus 1. Otherwise we will change the go toward the right half, which can be done by doing mid plus 1. I mean, we just moved the low side of the range towards the right. Now let's return if index is equals int max, then we do not find any. So in that case, let's return -1. Otherwise, we find the 1. So we will return index. So this is binary search for right index. So if we see that right index is not -1, then we can process. So current node right subtree will be equal to, we will give just a recursive call to right index and range is high and pre-order. Well, now if right index is not equals to -1, and current at left will be equals to same recursive call low high right index -1 and pre-order. Otherwise we will have current node left will always exist because the size is at least 2. We handle the size of 1. So we say low will be low plus 1 in the right index. That doesn't exist right index, so high will be, it will be high. And pre-order. Now we'll return current node. Well, let's go through the code. We find the pre-order size and we find the range. A range of initially range is full, and we passed it, and in recursive call we, if the range is mismatch, we will return null. Otherwise we will find the current value and then we form the current node using that current value, and if the size is 1, then in that case we are returning just that one. Otherwise we are finding the right index doing binary search, and in the binary search we find the one which is greater than x, and among all the values greater than x we try to go toward the left side by changing our high range to mid -1, and in this way we did a binary search and found a index which is uh, greater than the x, and also the one which is uh, lower bound among all the um, uh, among all the value which is greater than x. Well, in this way we return if it is if we do not find the index, then we are returning -1, otherwise we are returning that index. Well, first value, okay, we have to erase this. First value is already provided in the method in this function. So well, after finding this, if it is not -1, so binary search to return a value, then we will process both right node and the left node. And right node can, the range of the right node will be right index to high, and the range of the left subtree will be low to right index -1. Otherwise, we will just calculate left subtree from the range of low +1 to the high. Well, and then after processing everything that needed by the current node, that means the value, current value, and the right subtree, the left subtree, will return the current node. Well, looks good to me. Let's run the code and see whether there is any compilation error or what. Okay, compilation error at line number 27 and 25. Preorder. Typing mistake. Still 32. Current node. Current node. Okay, there is something wrong. Let's see what went wrong. Preorder. Well, the range is low +1. Well, the range over here is should be low +1. Yes, let's start with custom test cases with only one node. Let's return us that one. Let's try with the okay. Let's submit the problem. Well, it's accepted. 0 millisecond, 12.1 megabyte memory. Well, as I explained earlier, the time complexity is big O of n log n, and space complexity is big O of n. And according to constant, the time complexity looks good to me, and log n is fine enough. But we can also, I think, improve to big O of n. But currently I have big O of n log n solution. Maybe for big O of n, I may have to think further. Thank you so much. Have a nice day.